Alright, so welcome to the results session of our coding exercise. Coding exercise executed on a small data set. We have 2,000 training pictures, 1,000 cats, 1,000 dogs, and we have 1,000 validation pictures. 500 cats, 500 dogs. And we looked at a few methods. The first series is just Covnets, convolutional neural network, where we're actually going to try out dropout and data augmentation, and we will also look at different number of epochs. As you see, the Covnet here with 30 epochs gave an accuracy of 79%, and it overfits. It overfits quite early, from epoch number 5 onwards. So definitely not good. Now when we add dropout, with dropout we would expect an improvement, but we see actually a result that is worse, and despite dropout, 50%, it's still overfitting. So then we took the Covnet and data augmentation without dropout. And here you can see that the result is not different from this one here, but there is no overfitting. And if we take 100 epochs, our accuracy improves without any overfitting. So then we have the last scenario of this block where we have dropout and data augmentation, and both for 30 and 100 epochs. You see that for 30 epochs we reach the 80%, no overfitting, and when we go to 100 epochs we even reach 85% with no overfitting. Alright, and then we discussed the topic of transfer learning. And transfer learning is where you're gonna borrow a convolutional base of some network and try to extract features from it. Remember, there's two ways. There is feature extraction and fine-tuning. All of what you see now is feature extraction. Fine-tuning will be discussed afterwards. So, and we took, in terms of transfer learning, we took ResNet 50 basically, ResNet 50 as the convolutional base. And what do we see? Well, ResNet 50 with 30 epochs doesn't give us a good result, only 70.2%. If we add dropout, it's even going lower, below 70%. There is some overfitting here, but it takes a while, around epoch 17, whereas here the dropout reduces the overfitting, so there's no overfitting. Even when we do 100 epochs, we're still in the low 70s, which is not good. And then the last one is where we do method 2, meaning ResNet 50 with data augmentation. Remember, this is method 1, so all of these here are method 1. This one here is method 2. Method 2, where we actually have 4 layers instead of only 2 layers for method 1, and we freeze the convolutional base, the weights of the convolutional base, and we put epochs through these 4 layers. 30 epochs, and what do we see? Accuracy very bad, 50%, and immediately overfitting. By the way, for ResNet 50 plus dropout 100 epochs, there's also overfitting, but it starts pretty late, around epoch number 40. So, because of the fact that the ResNet convolutional base doesn't give us any improvement, we decided to look at VGG16 as well. We know the results are going to be better because it's the Covnet that is used by Francois Chollet in his book. So in this case we took VGG16, 30 epochs, and we have 90% accuracy. So that's definitely an improvement, but you have overfitting. Adding dropouts doesn't improve your accuracy, and you're still overfitting, albeit a little bit later. Yeah, this is almost immediately. This is from epoch 5 onwards, but this is still way too early. But if we look here at VGG 16 plus data augmentation, so remember, this is method 1, and this is method 2. Yeah, method 1 here, method 2 here. And because we looked through these 4 layers, actually method 2 takes a lot more time compared to method 1. But in method 2 we've been able to reach with 30 epochs an accuracy of 90% without overfitting. Yeah, so actually that situation is not too bad. So what we're gonna do next is we're gonna tackle the fine-tuning feature here. Now we will explain what fine-tuning is, and then we will do some quick coding exercises on fine-tuning and see where we end up.